Okay, guys, we got another day here of work. We're doing some more of these graphs of the sine and cosine wave. Just a little more complex here. So we'll just work on these harder ones. So this is the last time we'll look at these and we'll move on. And again, for some of you, this was something you understood before we left, but we had some bad attendance and just weird things going on. So I wanted to go back over. Okay, so now, guys, remember with the 7 there, that's that amplitude. So again, 7 up and then -7 down. Again, you can see I'm not really making it up 7, way up here, down, way down 7. I mean, you can just, as long as you label it 7, that's showing 7. Now remember, because there is a number on the x, that last dash changes. And remember, it's 2 pi divided by that number. Since that's a 4, I'm going to put it like that. So 2 pi over 4, which again, the 2 can cancel into the 4 and leave a 2. The 2 goes away since 2 goes into itself. So actually, that would just be left pi over 2. See, that 2 on top divides into the 4, leaves a 2 on the bottom. So pi over 2 would be that last dash. Okay, now guys, we kind of repeated this yesterday, same kind of thing. My middle dash is half of the half, which means really you're doubling that half. So that's going to be 2 times 2 or 4. Now what's cool, you kind of repeat that because the dash in between pi over 4 would be doubling or half of 4, which doubles the 4 to an 8. See that? Now, just like I've done before, now each dash helps me now find that third dash. So 1 pi over 8, 2 pi over 8, 2 and 8 would reduce to this, 2 pi over 8. So then this is 3 pi over 8. Okay? Hopefully that all makes sense. So again, 1 pi over 8, 2 pi over 8, 3 pi over 8, and then 4 pi over 8. See, 4 pi over 8 would reduce to that. So that all goes together. Okay, now let's graph it. I'll use the red for graphing. Now again, cosine, remember, starts high unless there's a negative. There's no negative in front, so it starts high, goes to the middle, then is going to go low. Okay, back to the middle, and then again, you always finish where you started. So back up high. Okay, connect our dots into our wave. And again, remember, guys, the wave could keep going. I just want to point that out. The wave keeps going. I mean, we're only going to go to the one loop. But it actually, if we could keep doing dashes, it would keep going forever. I mean, this is used in a lot of science stuff with waves, sound waves. I mean, obviously, water waves that water makes does have a similar, obviously, movement there. Okay, second one here. Now again, I've got a -3, but I'm still up 3, down 3, so that's a -3. Okay, the negative, remember, is going to flip us over when we do the wave. Okay, now here we go. Out at the end. Now remember from yesterday, when you don't have a numerator, but you have a fraction in the denominator, you put a 1. So we have 2 pi over 1/4. So 2 pi divided by 1/4. Now again, if you were watching yesterday, I can kind of think of 2 pi as 2 pi over 1. And then I'm going to reciprocal the 1/4. Remember, multiply by the reciprocal. So 1/4 flips over, becomes 4 over 1. The 1's don't do anything on the bottom, but 2 pi times 4, 8 pi. So that's saying that our last dash here is going to be 8 pi. Now this is actually a pretty easy one because watch, halfway out to 8 then is 4. Halfway to 4, half of 4 is 2. And then 2, 4, or halfway between 4 and 8 we know is 6. So that one's actually a pretty easy one to graph or to make the dashes for. Now the graph, remember, sine starts in the middle, no matter if there's a negative or not, because the middle's in the middle. But again, because of the negative on the 3, normally sine would go up, but it's flipped over. So sine goes down to -3. Okay, after it's down, it goes back to the middle. And again, since it was down, now it's going to go up to positive 3. And then again, it always ends where it started, which is in the middle. And then I just make my wave. Boom. And again, that wave could keep going. If I had more dashes, I could keep going with that wave. Okay, now let's look at the other side. These are the tough ones. Again, this is going to be the little harder ones, but we'll do it together here. Okay, these are the hardest ones you'll see. Okay, so I'm giving you some harder ones here. Okay, again, it's a -6, so that starts up 6, down 6. Now again, the negative is going to make us flip it over. Okay, I've got an 8. So 2 pi divided by that 8. Kind of like that other one. 2 went into 4. Here 2 goes into 8 and leaves a 4 on the bottom. So pi over 4 is actually that last dash, pi over 4. Okay? Now again, I mean, we're really repeating a lot of the same steps we did earlier, because if pi over 4 is halfway to pi over 4 is really half dividing 4 by a half, which really dividing 4 by a half doubles that 4. I mean, that's actually what dividing by a half does to the 4. So that's pi over 8. And then halfway out of here, so think about it. I'm going to take half of the 8, which actually doubles the 8. So that goes all the way up to 16, pi over 16. Okay, I know this, again, these are the hardest two I'm doing. And again, next year you'll be in pre-calc. We're going to do all this again. So if you're a little fuzzy, I know it's weird watching it online and stuff, but again, you'll get a chance to do this again next year. So 1 pi over 16, 2 pi over 16. See, 2 and 16 would reduce to that. So that next dash is 3 pi over 16. See that? And then this would be 4 pi over 16, which the 4 and 16 would reduce down to that 4. So those are my dashes. 1 pi over 16, 2 pi over 16, 3 pi over 16, 4 pi over 16. Okay, again, because I've got the negative, cosine usually starts high, but because the negative is flipped over, so cosine would actually start down at -6, go to the middle, go high, back to the middle, and then go low. And then again, just connect the dots into my wave. And again, the wave could keep going if I had more dashes. Okay. Last one. Now, I just wrote this one a little different because you might see something like this. Now, it's weird that I have a fraction, but guys, that's it didn't matter if it was a 6, over there was a 7. Whatever that number in front is my dash. So if the number in front's 1/4, then I'm up 1/4 and down -1/4. So hopefully that's not a big deal. Whatever's in front is the amplitude. Remember, that's called the amplitude. That is what I'm going to use for my up and down part. 1 positive, 1 negative. Now, again, I wanted to write it like this because you actually see the fraction, but guys, this is still a number with x. So that is still the number. And if you remember, on this one over here, we didn't have the 1, but we put the 1 and made a 1/4, okay, and that went in the denominator. So we're going to do actually a similar thing. It's actually in some ways easier because you already see the 1/3. You don't have to put the 1 there. So that's the number with x. So again, 2 pi divided by 1/3. Which is what we've done with those other fraction ones. And the 1/3 is already there. So again, the 2 pi, again, I can think of it over 1 times the reciprocal of that bottom. 1/3, it's going to flip to 3 over 1. So the 1s don't do anything on the bottom. 2 pi times 3, 6 pi. And that is my last dash, 6 pi. Okay. Now, again, this part's pretty easy. Halfway out to 6, then, would be half of 6, or 3. Now, this gets a little weird. So halfway to 3, I'm really dividing 3 by 2. I can't divide 3 by 2 without getting a decimal. So I just make 3 over 2. So I can't divide. I don't want to get like 1.5. That you don't write your dashes with decimals. So 3 pi, which is my middle, halfway out to 3 pi would just be 3 pi divided by 2. Now, just like we've done with those other ones, just jump. So 3 pi over 2. Double 3 is 6 pi over 2. See, 6 pi over 2? That's the same. 6 over 2 would make that. So 3, 6, 9 pi over 2. And then again, 3, 6, 9, 12 pi over 2, which 12 pi over 2 would make 6 if I reduced. Okay, so 12 pi over 2 does make that 6. Okay, now again, this is the hardest kind. Okay, it's kind of challenging, but let's graph it. Okay, though there's no negative with my fraction 1/4, so it's not a flipped over graph. So sine starts in the middle, goes up to the 1/4 on the top, back to the middle, goes down to the negative 1/4, back to the middle, make my wave. And again, it can keep going. And that's the graph. Okay, that's the graph for that one. Now, just if you watched yesterday's, I'm doing a similar one because these are hard to submit, your graphs. So again, on your journal entry, just put got it. And that shows me that you watched the video. And again, I'm just keeping track of people that do their work. Okay. Once we start getting into other problems where you can actually solve them, we will submit answers. Okay, I'll talk to you guys later. See ya. Bye.